Good morning, students. Today we are going to discuss about the capacitors. Introduction to the capacitors. Capacitor is a passive component like resistor. The name capacitor has derived from the word capacity to store energy. It was developed after discovered by Laden. The thing is, the capacitor will having the capacity to store the energy. The capacitor is a passive component. What is the meaning of passive component? The passive component will absorb the or will take the energy, but it does not produce the energy. It is not a current source or voltage source. It only it only the taker, not the giver. So that's why it is called as a passive component. Without any energy, it does not have any meaning. The name capacitor is given by the capacity to store the energy. The meaning is it is act as a storage element. It will store the energy. It is developed by the Laden in Laden jar in 1745. Capacitor consists of two conducting surfaces separated by a dielectric. Different types of capacitors have developed using different dielectric materials such as mica, air, etc. The capacitor having the two conducting surfaces, as you know that two plates are there, plate 1, plate 2. In between we having the dielectric material is there. This dielectric material is separates these two plates. Dielectric material means it is an insulating material. This material is used to store the energy in the form of the positive charge and negative charge. Generally, it may having the different materials like mica, wood, depending on the capacitance. We use the depending one. Sometimes it may not having any dielectric material, just like air also used as the dielectric material. You can see the capacitor how it is. A capacitor consists of two parallel plates. A capacitor consists of two parallel plates separated by a dielectric material. The symbol of the capacitor, you can see how it is. When a voltage is applied across the plates, the capacitor gets charged. It is a passive element. We can interchange the connections. Either way you can connect. The way where the current is entering, that will given as the positive terminal. The way the current is leaving is given as the negative terminal. So what is the actually capacitance? Capacitance. The capacitance of capacitor is the ratio of charge stored to the voltage applied. This is the actual definition of the capacitance. The thing is, the ratio of the charge stored to the voltage what we applied. Whenever you are applying the voltage, how amount of charge is stored, that storage is called as a capacitance. The capacitance mathematically represented as C equals to Q by V. where Q is charge stored units are coulombs and the V is the voltage applied across the plates. The meaning is the capacitance is the ratio between the star ratio between the charge stored in the capacitor and applied voltage to the capacitor, that is the Q by V. Q is the charge, the units of the charge is the coulombs, V is the applied voltage, the units of the V is volts. The capacitor is capacitance and its units are Faraday. The units of the capacitance is the Faraday. Already you know that. It may, in any circuit, the tendency of capacitor is to oppose any change in voltage is also defined as a capacitance. In general, if you take any circuit, each circuit may have the resistance, but and also it may have the capacitance property. The capacitance property is like that the circuit tendency to oppose any change in voltage is also called as a capacitance. If the circuit having the tendency to oppose the change in the voltage, that tendency is called as a capacitance of that particular circuit. Not only a component, the circuit may also having the capacitance property. You can see the capacitance how it is. We are in the circuit, what we are using is we using a capacitor and applied voltage and a switch is having the two position. Switch may having the closed circuit, switch may having the open circuit. Whenever switch is open, the applied voltage or the current not reach to the capacitor. Whenever we close the switch, the applied voltage is reached to the capacitor. We having the two positions, two diagrams are there. In the first diagram, we having the switch is open. When the switch is open, we don't having the any electrical activity. The second one is the switch is closed. When the switch is closed, the voltage applied voltage generates some current. The current is passes through the capacitor. You can see how we having the capacitor, the charging and discharging of the capacitor. The capacitor is like as a battery. Generally you can see just like example is mobile charger. Whenever we charge the mobile, charger will take the amount as in the battery. After if you use that mobile, the charge will be discharges. Like that, capacitor is like a battery. It charges the energy. After charging, it discharges the energy. The first circuit you can see the circuit is open, no charging in the circuit. Whenever the switch is open, no electrical activity. As I mentioned earlier, there is no electrical activity. Then the capacitor does not charge anything. Coming to the second circuit, you can see in the second circuit the switch is closed. When the switch is closed, what happens means the whatever the positive voltage is there, the positive charges are reached to the capacitor plate and negative charges are reaches to the negative terminal of the applied voltage onto the second plate of the capacitor. These charges stored as a positive charge on the first plate, negative charge on the next plate. These in between these two they having the attraction, but in the middle we don't having the physical contact. These two are physically separated. Because of this electrostatic attraction, the charge will be stored on the capacitor. You see here how it is. The capacitor having the positive charges on the upper side plate and negative charges on the downside plates. After charging, what happens? You can see the third diagram. After charging, the total charge source is removed. What we are doing in this, the applied voltage is removed. Now the capacitor is discharging in opposite direction. The thing is, applied voltage, whenever using the applied voltage, the total energy is stored as a charge in the capacitor. Now in this diagram, what we are doing is we remove the source. After removing the source, the stored capacitor is try to discharge the energy in the reverse direction. Again, the capacitor is discharging in opposite direction. Opposite direction means that is charging is the plus. Now it is discharging. So that's why in the opposite direction it try to discharging whenever leaving and entering we can take as a plus. Here what we are getting is opposite, means the plus become the minus, minus become the plus, like that it is discharging. If you connect any load to this circuit, then the capacitor is act as a energy source until the energy stored in the capacitor goes to zero. It is act as a energy source. Now we try to see charging and discharging of capacitor in detail. When switch S is open, no voltage is applied across the plates of the capacitor, as we mentioned. When switch S is closed, electrons from negative of battery moves to the plate A of capacitor. When the switch is closed, electrons from negative of battery moves to plate A of capacitor. After that, the free electrons from the plate B of capacitor moves towards positive terminal of battery. Due to electrons on plate A repels the electrons on plate B. Now what happened? Now plate A is negatively charged. After that, plate A is negatively charged means then plate B is positively charged because of deficiency of electrons on a plate B. The plate B having the negatively charged electrons, they opposes the electrons on the positive plate. So in the plate B, it does not have any electrons. Plate B is positively charged because of deficiency of electrons on plate B. So potential difference is created between plate A and plate B and the capacitor get charged. The potential difference is created between the plate A and plate B. In this way, the energy of applied voltage is stored on the capacitor plates A and B. This charging process constitutes a current through the capacitor. This charging process constitutes through a capacitor, as we mentioned. This process continues till plate A becomes negative terminal of the battery and plate B becomes positive terminal of the battery. The meaning is the total amount of negative charges are reaches to the capacitor plate A. Total amount of the positive charges reaches to the plate B or the capacity of the capacitor. Maximum amount of capacity what the capacitor having, that amount if it reaches, it will stop the charging. So this is after charging. So next method is there, next step is there. Now we close the switch. Next we try to open the switch. If we open the switch, what happens? Already we discussed. Once again we try to see. When switch is open, initial switch is open. After we close the switch, after closing the switch, some operation is takes place. The capacitor will be charged. After charging, now I am opening the switch. What happened? When switch is open, the surplus electrons on plate A and deficit electrons on plate B of the capacitor will stay. The capacitor is said to be charged to the voltage of battery. The meaning is whatever the surplus electrons on the plate A and deficit electrons on the plate B of the capacitor will stay there. Now the capacitor is said to be charged. If plate A of capacitor is connected to plate B of capacitor through a copper wire, the surplus electrons from plate A flows to plate B and neutralized the positive charge on the plate B. Whatever the things are there, the plate of capacitor connected to plate B, the electrons from the plate A flows to the plate B and neutralizes the positive charge on the plate B. The flow of electrons continue till all the surplus electrons at a plate A moves to plate B. Now the capacitor is said to be discharged. The meaning is whatever the negative charges on the plate A is passes through the copper wire and reaches through the plate B. After reaching the plate B, it neutralizes the energy so that the amount of energy stored in the capacitor may goes to discharge. So this is called as a discharging. Like this, the capacitor is charges the energy. After charging, it discharges the energy. Charging and discharging is the property of the capacitor. Now we try to discuss different types of capacitors. Now we define only the capacitance. What is the capacitor behavior? How the capacitor is there? What type of operation is found in the capacitor? We discussed. Now we are going to discuss about the classification of capacitors. You can see classification of capacitors. You know that capacitors are classified so many ways, so many varieties of capacitors are there. Some basic important classifications here we are going to discuss. Capacitor can be classified on the basis of nature of value, type of dielectric material we are using, polarity. The classification, simple classification is, first classification is nature of value. What is the meaning of nature of value? Whether the capacitor value is fixed value or changeable value, or if one capacitor is used for only one value or another value also. That type of thing is called as a nature of value. Again we having the classification in the nature of value. Next one is the type of dielectric material we be using. Dielectric material, you know that dielectrical material is the insulating material. If we use the dielectric material in the capacitor, it increases the storage capacity of the capacitor. If we use a super dielectric material, then the capacitor is act as a supercapacitor, means a high storage capacity may have the capacitors. So that's why the capacitance are classified as type of dielectric material we are using. Depending on that, again we having the different classifications are there. Another one is the polarity. So the polarity is what type of things we are using. Polarity means positive terminal, negative terminal means some of the capacitors don't having any polarity, but specifically some of the capacitors may having the polarity. So again depending on polarity, also with polarity, no polarity, and without polarity, like that we having some another classification also there. Now we try to discuss these three classification, how they further classified. Next, nature of value. You can see on the basis of nature of value, again they are classified as fixed value capacitor, variable capacitor. I already mentioned that nature of value means what type of values those capacitors are possessing, whether the values are constant values or the values are changeable values or variable values. Depending on that, we having the two types of capacitors are there. The first one is the fixed value of capacitor, second one is the variable capacitor. Variable capacitor. Well, again we having the another classification, fixed types of capacitor. What is a fixed capacitor? Fixed capacitors are those for which the value of capacitance is constant and cannot be changed. The meaning is, if the capacitor, if you wanted to use that having the only one value in any circuit, use that it having the only one value, that's why it is called as a fixed capacitor. Another one is the variable capacitor. Variable capacitors are those for which the value of capacitance can be changed by adjusting the sum parameter. Adjusting the sum parameter. Those are called as a variable capacitor. Sum parameter means we having generally three parameters, that is area of the plates. If you change the area of the plates, the capacitance value changes. Next one is changing the dielectric material, the value is changes. Area of the one, the distance between the, if you change the distance between the plates also, the value of the capacitance is changes. So depending on that, the variable capacitors are designed. This is the another classification, fixed capacitors and the variable capacitors. Now we are going to discuss the next classification. You can see on the basis of the dielectric material we are using. So the thing is, the next classification is what type of dielectric material we are using. Depending on dielectric material, we are saying that the type of capacitor. The importance of dielectric material is, if the dielectric material is perfect, the storage capacity of the capacitor is increases. The first classification is paper capacitor. In this, the paper is used as the dielectric material, that is in between the two plates the paper is used. Next one is the ceramic capacitor. Ceramic means they used the ceramic as the dielectric material. Ceramic material is used as the dielectric material. You can also use as the mica. If you use the mica, that capacitor is called as the mica capacitor. If you use the plastic film, then it is called as a plastic film capacitor. If you don't use any dielectric, that is called as air capacitor. If you use the glass, That type of material is called as a glass capacitor. The meaning is paper, ceramic, mica, plastic film, air, glass, like this. Depending on the dielectric material, these are the classifications. So on the basis of polarization we may having like this: polarized capacitors, semi-polarized capacitor, non-polarized capacitor. The meaning is depending on the polarization we having the three types: polarized capacitors, semi-polarized capacitors, non-polarized capacitors. Polarized capacitor means the two terminals are polarized. The meaning is it may having the positive lead and negative lead. It directly we can see by seeing the leads we can identify the capacitor positive lead and negative lead, and also we need to connect in the same way wherever we need the place. We need the capacitor positive lead, wherever we need the negative we use the negative lead. Next one is the semi-polarized capacitors, and third one is non-polarized capacitor. Generally used capacitors are the non-polarized capacitors. So these are the classifications of the capacitor. Now again we try to discuss about some classification of capacitors in detail. The first topic is fixed value capacitor. In the fixed value capacitor, what are the different capacitors we have and what we need to do, that's we are trying to discuss. Fixed value capacitor, the first one is the paper capacitor. The thing what we are saying is, here we are using the paper as a dielectric material. The classification is fixed value capacitor. The value of the capacitance is not changed. These capacitors employ paper as dielectric material. The paper is used as a dielectric material. These paper sheets are impregnated with oil or waxes to prevent absorption of moisture. We using paper, okay, it is better, but how the paper sheets are impregnated, these are impregnated with oil or waxes to prevent or absorption of the moisture So next, impregnation also increases dielectric strength. The thing is, if we impregnated with oil or wax, this oil and wax also improves the dielectric strength. These paper sheets are wound with thin aluminium foils. These are wound with the aluminium foils. So this is about the paper capacitor, how the paper capacitor is manufactured, how it is. You can see in the 4 points. Further, contact to aluminium metal is made by welding the leads to it. What they are doing is they welded the aluminium metal. Contact to aluminium metal is made by welding leads to it. Then the capacitor is encapsulated in a metal can or in a resin. That is encapsulated in a metal can. The structure is like a can or in the resin. The size of capacitors can be reduced by metallization of aluminium by vacuum deposition on a paper sheet. Like that, we try to reduce the size of the capacitor. So these are the plastic capacitor what we are discussed. Now, next capacitor we try to discuss is the mica capacitor. What is the mica capacitor? Mica capacitor. Mica is naturally occurring substance having dielectric constant of 8 and can be laminated into very thin sheets. Dielectric constant of mica is 8. That is a very good dielectric constant value, and we can also make them very thin sheets. Very thin sheets. Mica can be used up to 500 degrees centigrade. Up to 500 degrees centigrade, the mica is used as a proper dielectric material. These micas are impregnate like polystyrene or used to improve the properties of mica. This mica is impregnated by using the polystyrene. Silver electrodes are metallized directly on the sheet of mica, and this assembly is molded in plastic or dipped in resin. After getting the silver electrodes, this is molded in plastic or dipped in resin. So we make the mica capacitor. The next one is ceramic chip capacitor. Ceramic chip capacitor. So here what we are using is ceramic as a dielectric material. These capacitors can be used without leads and body encasement. This type of capacitor don't having any leads and any encasement. These capacitors can be directly attached to film circuit or PCB. This type of capacitors are directly attached to the whatever the circuit we are using, that circuit, or to the printed circuit board. This chip capacitor is made up of alternate layers of thin ceramic dielectric and conducting surface. The meaning is it is made up of a alternate layers of thin ceramic dielectric and conducting surface. The meaning is one layer is ceramic layer and another layer is conducting layer. Ceramic layer and conducting layer. Like that we get the capacitance property of the chip type capacitor. These are compressed and fixed to from a monolithic block having appearance of a single piece of ceramic. One after one we make the number of sheets. After making that, this is can be appeared as a single piece of ceramic. It having the high capacitance capacity is there. This is used directly on the PCB. This is a ceramic chip capacitor. Ceramic chip capacitor. Now next capacitor. You can see next capacitor, plastic film capacitor. Plastic film capacitor. These are the important capacitors. How they are manufactured, what type, how they are. We are discussing. Plastic film capacitor. Polymeric materials can be prepared as dielectric. Plastic means different type of plastics are there. That is the polymeric materials are there. Those materials can be used as a dielectric. What is the importance of this polymeric materials is they can be formed in thin. The size of this polymer material is very thin and highly uniform and non-porous. Highly uniform and non-porous means the structure of these polymers are uniform uniformly is there, so that the charge, whatever the charge is charged in the capacitor, is uniformly charged, and there is no leakage, and high dielectric strength also there for these polymers. That's why we use the polymer material as a dielectric material. So these also two types are there: plastic films, metal foil, metallized foil capacitor. Metal foil is one, another one is the metallized foil capacitors are there. So these are the basic two classifications of the plastic film capacitor. The film is a polymer materials. It may uh, having the capacity of very thin and uniform and non-porous, and having the more dielectric strength. That's why we use the plastic film capacitors. Next, we try to discuss other type of plastic capacitor. You can see so many are there. Other plastic filling capacitor, you can see polyester capacitors, polycarbonate capacitors, polyethylene capacitors, polystyrene capacitors, polypropylene capacitors, Teflon capacitors. Like this, depending on that material we are using for the dielectric, those are called as a those are called by using that name, that is a plastic filling capacitor. All these are the plastic polymers. So this is about the fixed value capacitors. Some of the capacitors which we have discussed: ceramic capacitor, paper capacitors, plastic capacitors, and ceramic chip type capacitors we discussed. So these are the sum of the fixed value capacitor. The capacitor having the fixed value, the value does not changes that. Now we are going to discuss about the next topic, that is the specifications of capacitors. So what is the capacitance specifications? Actually, what is the meaning of specifications? What specification says that what the component having, whether the component capacity how much, what are the different materials we using, what is the material strength, what is its tolerance, what is its working voltage, and what is its dissipation factor, what is its power factor. Like that, total behavior, total values, total information about that particular component is given by the specification. By using the specification only, we choose the components. For our application, what type of specifications needed, we choose that specifies the component, so that our need is matched with the component specification, then our designing is perfect. Now we try to discuss general specifications of the capacitors. Different specifications of a capacitors are generally: capacitance. What is the capacitor capacitance? How much that component offering the capacitance? What is the capacitance storage capacity it having? And next one is, what type of dielectric constant or dielectric material we are using? What is that dielectric constant in the values, what constant it having, and what is the strength of the dielectric material. If we don't having strength, if our application needed the high strength capacitance, if we use the low strength capacitance, it mismatches there, and the capacitance may go to damage or may don't give the correct values. So it also it also gives the dielectric constant values and dielectric strength values and tolerance. If we mention some value, how much how it have correction, how much positive value it have, how much negative value it have, that is given by the tolerance. And working voltage or voltage rating, the maximum allowable voltage through that component is called as a voltage rating. Beyond that voltage rating, if you give the voltage, the device may goes to damage. So that's why we also know that working voltage of the particular component. So what is the dissipation factor? Another important specification is dissipation factor. The thing is, dissipation means it is charging well, but it is discharging very fastly. So what is the use of that components? So that also we should know, that is how much it is, in what time it is dissipating the energy, that is given by the dissipation factor. Dissipation factor also very important. The next one is the power factor. The power factor of the device, it will give the how much power it can withstand. Power related values can be calculated by using the power factors. That's why this the power factor also very important. So these are the some of the specifications. We can see capacitance, dielectric constant, dielectric strength, tolerance, working or voltage rating, dissipation factor, and power factor. Again, we may have some more specifications also there. So the other one is equivalent series resistance. The meaning is, what is the equivalent series resistance? Whenever you use this capacitor in the circuit, how much resistance it is offering, also we need to know. If that component offering more resistance, it does not allow the current flow through the circuit, so it may alter the functioning of the circuits. That's why we need to know equivalent series resistance of the capacitor. And the leakage resistance, how much the resistance is leakage it having. The meaning is, it offering some resistance, after that how it is decreasing that particular resistance. Another one is insulation resistance, how much it having the opposition capacitance is. Insulation resistance, what type of temperature coefficient it capacitor having, whether the capacitor is depends on the depends on the temperature or not, that is given by the temperature coefficient. Another one is the voltage coefficient, how much the voltage, if you apply how much voltage, how much it is withstanding, whether the capacitance value is changing or it is uniform for the different values, that is given by the voltage coefficient. And the last one is the stability of the capacitor. Stability of the capacitor. So that is also we need to use that stability of the capacitor. So what is the stability? Stability of the capacitor means whether that capacitance having the stable values or not. We also have the how much percentage of stability is there, that also we need to mention in the specification. The meaning is, the specification provides the total behavior, total values, character of a particular component. So that's why in the specification, in the specification sheet, the component having the all the values, whatever it having, all the coefficients, all the constants it have. By seeing them, we can use that particular component at the suitable applications. So these are the specifications of the capacitance. Already you know. So once again we try to see the specifications of the capacitance. Capacitance of the capacitor. How much capacitance it is offering. Dielectric constant of the capacitor. Dielectric strength of the capacitor. Tolerance of the capacitor, how much it having the tolerance, its value should be specified. and working or voltage rating of the capacitance. The meaning is for what voltages it is working, that is a working voltage of the capacitors, and dissipation factor of the capacitor. What is the value of the dissipation factor of the capacitor, and the power factor of the capacitor. Power, what is the power factor, and remaining is equivalent series resistance when you connect the component. So what is the equivalent resistance, and leakage resistance, how much it is leaking, and insulating resistance, temperature coefficient, and voltage coefficient, and stability of the capacitance. So this is today's class. Until we discussed about the definition of the capacitor, general formula of the capacitor, units of the capacitor, classification of the capacitor, different classifications, that is depending on the nature of the capacitor, depending on the dielectric material which we are using, depending on polarity which the capacitance having, we having the different classifications are there. Again, in the three classification we further divided into the different types of capacitor, and we discussed about the fixed value capacitors. Those are paper capacitor, plastic capacitor, ceramic chip type capacitors. We discussed how they manufactured, what type, what is there in the capacitor. We discussed. At last, we discussed about the specifications of the capacitor. A capacitor must know, whenever we are using the capacitor, we must know these type of specification. Then only we can use the capacitor in a proper application, in proper way, right application in a right way. Thank you. Remaining topics are covered in the next class. Thank you.